since you built two of them
Hmm.
and they're both not working in exactly the same way,
Yeah.
then the instructions are probably wrong.
Hmm.
So let's see if we can, because I have working units here, let's see
Yeah.
if we can find the discrepancy between the unit and the instructions. Partly because you don't have a meter there, and partly because I think the fault is in the instructions. Um, what we're going to do is you're going to read out the instructions, and I'm going to buzz out my working unit, and we'll see if we can find where the discrepancy is. How about that?
Sounds good.
And if it turns out to be a problem with the instructions, I will apologize profusely because that really sucks for you. Um,
Yeah. So I guess the first thing I did was I cut the traces between
between
A, B, B, C, and C, D.
A,
Or
B, B,
I'm sorry, one and two, A, B, B, C, C, D.
okay, A, B, B, C, C, D. Okay, yeah.
And then I cut the traces between one and two, H, I, and I, J.
Okay, H, I, and I, J. Yeah. All right. Then what?
Then I soldered on the 4-pin magnet coupler, A, B, C, A1, or one, A, B, C, and D.
Okay, yep. Um,
And
did you use the flat pin side or the
yep,
pokey pin side? Okay, flat
the
pin side.
flat pin.
All right.
Yep. And then I soldered on the 3-pin magnet coupler to one HIJ.
Okay. So far, so good. I have a little loose piece of an LED lead stuck to the back of my connector here. That would be bad. So glad we spotted that. All right, what's next?
Then I set up the microcontroller.
Okay,
Um,
so let us check that you put the microcontroller in the same place that I put the microcontroller. Um,
so I have
so
my
show
microcontroller.
me your board, please.
Do you want to see the back so you can actually see the?
Right, that's what I want to see. Um, okay, so we have it in the same orientation. That's really important.
Yeah.
And it is in I and C,
Yep.
and it is not in row 60 or column
Nope.
60. Okay,
Nope.
but it does
I have it
go
in
from 59
40.
all the way to 44.
Yep. And then for I, it's 44 to 55.
Okay, all right. That looks like we got the same thing. And
Um,
at this point, just to clarify here, your rotary encoder is working, right? The
I
test
didn't.
code for the rotary encoder on the other one.
Oh, and the other one. Yep.
Yeah, yeah. Okay.
Yep.
All right.
Um, then I grounded the microcontroller. So I have a black wire going from A56 to the negative below it.
Okay, so A56, negative below it. Okay.
And then I have a red wire from A57 to the positive below it.
A57 to the positive below it. Okay.
I have a green wire going from J45 to the negative above it. And a white wire from J44 to the positive above it.
Okay. We will no longer refer to that as positive. We refer to that as SDA, and the green one will be S clock. SC, no,
Okay,
SCL,
SCL. Okay.
or the I
Then
squared
I
C
ha
bus clock and the I squared C bus data line. Okay.
okay.
Next.
Then I have a black wire from uh B2 and it goes to ground, and then I
Okay.
have it in the back shorted from B2 to B1.
Okay. So B2 on the ground. Okay. Let us be a little bit more efficient here to get started, and then we'll go back and do it one by one if we have to. Um, you
Okay.
know that the um, I squared C bus is working because you can use the touch screen,
Yeah.
right? The touch screen responds to touch and gives you location. So we
Yep.
know that there's not a problem with the I squared C bus or power and ground. And we know that at least some of the wires are getting to the display connector and that the display connector is actually getting to the display, right?
Yeah.
Okay.
So just stick to the display core, the display wires.
So let's do this backwards. We'll go from the display unit to the microcontroller. So let's start with TCS, which I have in 32A.
Yep.
And I
To
see that going to let's see, that would be that. So what number is that? Number's a little hidden. 51,
yep. J51.
J51. Okay, so we did
Yep.
that one. Um, our ST doesn't go anywhere. Um, so we're going to do DC. So this is the data command line from the microcontroller to the display. I have that on 30. So it's
E30. Oh yeah.
A30. And I have it going over to 50, J50.
I have mine on B30 to J50, but those should be the same
Oh,
because they're,
B30 to J50.
yep.
Yep. In fact, I have mine on B30 also.
Okay.
Okay, I just misread that. Um, all
Yeah,
right.
much harder on yours, I imagine, with all of the wires installed.
It's okay. Not too bad. Um, I am very disappointed that you're having a terrible time. That's what I'm mostly disappointed about. All right, let's take MISO.
Okay.
Um, so I am seeing 29, and it
Yep.
could be either A or B, depending on which order you did these in.
Yeah,
And
I have
that
mine on
comes
A.
over to
I have mine
you.
at A47.
Okay.
So A29 to A47. And
And
then
MOSI, so main out, serial in. So this is the input line to the display from main. And that I have going to, what do you have?
I have A28 to
Uh-huh.
A48.
To A48. Okay. All right. And then we'll do SCK
I have A27 to A49.
to A49. Huh. Okay. Yep. All right. And then I've got nothing else on the remaining three pins on that
Uh,
side of the display.
Not grounder.
Ground light or VN. No, nobody there.
Oh, I have a ground there.
Oh, that's because they're buried. My mistake.
Oh, okay. I have ground and
Okay, so
power.
VN is VN and
I
ground
have,
is ground. Okay.
yeah, easy
Yep.
enough.
Good. All right. And we know that SDA and SCL are in the right place
Yep.
because the touchscreen is working. The only other thing we have there is the interrupt. Where's the TCS is the chip select line. Okay. The interrupt shouldn't really cause us anything at all, but so I have that in H29.
I don't have anything that needs 29.
What's that?
I don't have anything at age 29.
How about J29?
Uh, nope. Oh, let me look at the other one.
There should be a purple wire from really HI or J29 to
Let's see.
J52.
I have purple from I have purple from B39 to B51, and that's the
That's
rotary
way on the other
encoder.
side. That's related to the
Yeah,
rotary encoder. Yes?
yeah.
Okay.
And then the other time I have purple is in the SD card.
Okay. So there should be a purple wire.
Okay, let me go back then.
Okay, so first write it down and then we'll go back and see if it's missing any
Yeah.
instructions. So
So it should be from
J29
J29
to J52.
to J52. That should be purple.
And that should be purple. And on the display end, it's INT, which is the interrupt line. But that is related to the touch screen. All that does is send a signal when the touch screen is touched. And as far as I know, we're not using that in the software. So the fact that you don't have that wire there should not be causing you any problems. Okay, so let's go back. Now that we have identified all the wires, we'll go back to the main ones. We're pretty sure of MISO, MOSI, and S clock. Let's go back to the chip select line. So it's going from TCS
Hmm.
to J50, which? J51? Yeah.
Yep, that's what I have.
Okay. Can you see underneath that wire the solder joint at that particular location on the back of the microcontroller
At J51.
at J51?
Yes.
Okay. Does it look good?
Yeah.
Okay. And then on the other side, where the pin comes through and is sticking out on the high end,
Yep.
does that solder joint look good?
Yeah.
Because those ones on the high pin have a tendency to ball up at the bottom and not make contact.
Oh, they look good.
Okay, so it looks like a volcano and not like a pear sitting on a post.
Yeah.
Okay, all right. Hmm. And you don't have wires going toward the magnet connectors from the display. That those wires would be for the SD card. You haven't done that yet.
Yeah.
Okay.
Nope, I don't have any of those.
Okay. So there just aren't any wires there,
No.
which is good. Um, all right. This one is working. I'm going to open another one that's working. And this is why we want somebody who's never done this before to edit the instructions.
Mhm. Yeah.
And you win the bravery award for coping with ridiculous amounts of frustration.
Thank you.
I think I built both of these at exactly the same time, so they really ought to be exactly identical. And besides, they're both working. Okay,
Yeah.
so meter check, and we're going to go TCS, which is in A32, right?
A32. Yep, that's TCL or TCS.
Yep, to J51.
Yep.
Okay. Let's start from the other end this time. S clock. S clock goes to A59. And MOSI,
Wait, what goes to A59?
S clock goes to A59. Oh no, sorry, A49.
Oh, I was gonna say I don't have that there. Yeah, yeah, A49.
Okay, so A49. And Um, and MOSI goes to 5.8, and MISO,
4.8.
sorry, 4.8.
Yeah.
And MISO goes to 4.7.
Yep.
Okay, those are all working. You have all those wires. Hmm.
And I did check them with the multimeter, like when I was, when it wasn't working yesterday. I
Yeah, no,
did
you
test it with the
poked everything
multimeter,
you could
so
poke. Um,
yeah.
on the back of the display, did you close the little black latch to hold the ribbon cable in?
Yep. And the ribbon, I mean, I guess let's just ask everything at this point. The ribbon cable is like silver side down, blue side up.
Yep, blue side up, silver side down.
Yep.
Um, and you've used two different displays at this point.
Two different displays and two different ribbon cables and every combination with
Okay.
both Stellas, interchanging both of them.
Yeah. All right. So I am 0 and ground should not be connected, but I am 1. Mm, no, wait. It's 3 volts. What are we looking at? VM. That's really, really weird.
Yeah, I agree.
And Mike has built from these instructions, and I
Yeah,
wasn't standing over him while he built them. Um, and it's not a like individual Bianca issue because
I
there
would
isn't
hope
anything
not.
unique about Bianca except that she hasn't done this before.
Yeah, I mean, and Matt used his logic analyzer to test whatever that tests.
Okay.
So I,
Yeah, yeah,
whatever
yeah.
that is, we can cross that off.
Um, wow.
I'm not glad you're frustrated, but I'm glad I'm not the only one who doesn't understand what's going on right now.
I do not understand what's going on right now. And I've built lots of these things and I designed it. Um,
Yeah,
so I do not understand what's going on. And at the moment, I cannot duplicate the problem, and you
yeah,
cannot make one that does not have the problem. So you have you
yeah,
have you have an exact duplicate of the exact
hmm,
same problem,
yeah,
right? I mean, you fired it up and you tried
yeah,
it, right?
yeah,
And you loaded the touchscreen test code and it worked, and you loaded the
yep,
other test code and it did not work.
yep.
All
I
right.
mean, I guess, are we like positive it's the same version of the code? I mean, that's the only other thing I can think of, but I don't know how many versions of this code
Okay.
exist.
So there was a version that went with the earlier version of the 1.2 that had different chip select pins.
Okay,
Okay. And that would cause that to be a problem. Um,
okay,
so what I'm going to do right now is I'm
okay.
going to go to my test code. Um,
Hmm.
and so this is my current test code, and it's a main unit test code, and it is 2.8-inch TFT display.
Yep.
And it is code.py. And I'm going to, excuse me for a second while I grab a cable.
Okay, I'm also gonna actually go grab a cable.
Yeah. All right. So I'm going to take this test code and I'm going to open Mu just so I have that running. And I'm going to CircuitPy. And I'm going to take my test code and overwrite what's on CircuitPy. And this is what I'm seeing.
Okay, hang on.
Okay.
Yep.
So now, um, let's do this. Um, open your So in Mu Editor,
Hmm.
so load your test code if it's not already on there
All right,
onto
sorry,
your
give me one
thing.
second. We plug in the display again.
Yep.
You would think I'd be a pro at it. How many times I've taken it off and put it back in, but
Yeah, you get to be better at it when you're doing it in a lighthearted mood and not in a sunken, depressed mood.
yeah. There we go. Let me plug this guy in.
One other idea. So we'll try this and then we'll try the other idea.
Okay. Do you want to share my screen?
Um, no, let's just read side by side.
Oh, okay, okay.
Okay.
Yep.
Um, so line one says import time,
Import
right?
time. Yep.
And then you read line two,
Okay, import board.
and line three is import display IO
Import terminal IO.
from Adafruit display text import label.
Um, import Adafruit underscore ILI 9341.
Right. That's the display controller chip. Um, okay. From four wire, import four wire. Oh, it's blank, so it's my turn to read again.
Then skip to 8.
Nothing in eight. Okay. Display IO
Yep.
dot release displays. Nothing in
And
10.
it's blank again.
Right.
Yeah.
SPI equals board dot capital SPI open close parentheses. Okay.
Yep.
Next.
And then TFT underscore CS equals board dot D12.
Capital D.
Yep. Capital D, I'm sorry.
Okay. No, no, no. I'm just checking. Um,
Yeah.
all right. And I have TFT underscore DC equals board D1111.
Yep.
Okay.
And blank.
Um, nothing in 14. Display bus equals four wire, comma, SPI, command equals TFT
Wait, wait,
underscore
wait. Four
DC.
wire,
Display bus
four
equals
wire. Okay.
capital F for capital W wire,
Yeah. Yep.
parentheses, SPI,
Yep.
comma,
Yep.
command equal TFT underscore DC.
Hmm.
Okay. And comma after that. And chip underscore select
Yep.
equal TFT underscore CS.
Close parenthesis.
What's that?
Yep. And then the closed parenthesis.
And close parentheses. Right. Okay.
Yep.
Read line 16.
Display equals Adafruit underscore ILI 9341 dot capital ILI 9341 parenthesis display underscore bus comma width equals 320 comma height equals 240 comma rotation equals 0 close parenthesis.
Right. Okay. And then there's a little print thing that says initialize the display. When you
Yep.
run this code, um, so if you go into save or control C, control D or something like that and run the code, does it print out the initialized display part? It
Yep.
does. Okay.
Yep.
Let me see if I can think of anything that would bite us. All right. Um, so 19 is my turn. You wound up with all the even ones.
Yeah, I know I left
Display
out.
underscore group equals display IO dot capital G group parentheses, and then 20 is yours.
Display dot root underscore group equals display underscore group.
Right. Okay. Color underscore bitmap. Oh, that's yours. It's even.
Oh yeah, yeah, yeah. Color underscore bitmap equals display IO dot capital B bitmap 320 comma 420 sorry parentheses 320 comma 420 comma 1
Okay.
close parentheses.
And I have color palette equals display IO capital P palette parentheses 1.
Yep. Color underscore palette bracket 0 equals 0x capital FF 0022
Okay.
pound.
Yep. Um, And we have background equal, I'm reading it even, whatever, I don't care anymore.
Oh, sorry.
Background equal display IO, capital T tile, capital G grid, color underscore bitmap, pixel shader equals color palette, equal X equals 0, Y equals 0.
Yep. And
Um,
then display underscore group dot append parenthesis background.
right. So here's the thing. At that point, it should be working.
Yeah, because this is all just like visual stuff.
Right. Now, okay, a couple things that could happen. One
Yeah.
is that for some reason it's not doing the loop underneath. So it comes on and then turns right back off. And so you would never see it. It literally not enough time to see it.
Oh, okay.
Um, so let's do this. Under line 42, while true,
Mhm. Yep.
insert a new line above line 43.
Okay.
And you're going to say print, open parentheses,
Hmm.
quote, double quote, regular
Hmm.
old double quote. What swear word would you like to use? A WTF, maybe?
Test. No, I just want to do test. We'll
Okay, test.
just don't want to anger it anymore.
Oh, okay. So you're going to print test, and then close the quotes, and then close the parentheses.
And it
Okay.
prints test.
And when you run that, it prints test?
And that's before the while true, right?
No, no, after the while true.
Oh, after the while true. Okay.
We want it to print test every time it goes through the loop
Ah, okay.
to make sure it's in the loop.
Gotcha. No, just prints test once.
It
So
prints,
while true,
yeah,
print test,
yeah. Time dot
time
sleep
dot
two.
sleep to count plus equals one, text area dot text equals, more format count.
Okay, but it only prints one test once.
Yep.
Well, that's weird.
Let's see. Let me try this again.
Okay, just for clarity here, share your screen so I can look at your code and make sure we're talking about the same thing.
Okay. Now it says invalid syntax error. All right, let's share my screen.
Yeah, maybe there's an indent
Um,
error and we'll figure that out.
okay.
Ah, okay. Right before that print, hit the tab key. There you
Okay.
go. And try it again. Invalid syntax. What line is the invalid syntax?
45.
Okay. That's really interesting. Um, all right.
Yeah.
What's going on here? Well, true. Print, testing, time.sleep 2, count plus equals 1. Did you, save again.
Oh, okay.
And, oh, there it is.
Oh,
Okay.
now it's showing up.
So
Okay.
you're in the
And
loop.
yep,
So we know that that loop is persisting.
yep,
Um, and just for clarity to save ourselves a headache later, um, after where you've written testing,
yep,
put a space before the quote, and then do curly braces, open close curly braces. And then after the quote, type dot format, all lowercase, parentheses, count, close parentheses. So there should be two close parentheses there. All right. So now save that and let's see if that's doing what we hope it does. Okay, so now you can see where you are in the loop. How many cycles have gone by?
yeah,
And it's doing what it's supposed to be doing.
yeah.
Okay. So Now, let's go to, all right, so not main unit test codes, but in code and libraries, Stella 1.2 code and libraries, are you using uh latest stable version or latest version unstable? Where are we getting this from? No, wait a
Uh,
minute. That was so test codes are there. Right. So go into Stella 1.2 code and libraries and let me know what you see there.
yep. Library code.py settings.toml.
Okay. So I'm going to assume you're using this one, and then we'll open lib. And there should be an Adafruit underscore ILI 9341.mpy.
Adfru underscore, what is it?
ILI
Oh, oh,
9341.
ILI 9341 dot MPY.
Okay. What is the date modified on that?
11/17/2025.
11/17/2025. Okay. Um, so that'd be November 17. Oh, that's probably when you loaded it. That doesn't really have
Yeah,
very much. Can you get the size of that file?
yes. 1 kilobyte.
Okay. Um, yeah, it's 627 bytes, which would round to 1 kilobyte. So
Oh,
I'm going to email you this library file
okay. And then copy it over.
and then copy it over to your CircuitPy drive in the lib folder.
Yep,
And it'll ask you if you want to replace, and you say yes,
replace
and it'll
it.
replace.
Gotcha. Hold on, let me reopen it in Mu.
Oh, yeah.
Load code.py serial. Testing 18, testing 19, testing 20, and yeah, no change on the display.
Okay. Go ahead and Control C and Control D just to make it run again.
Yeah.
Make sure it's getting the library.
Yep. Initialize display, testing 0, 1, 2, 3, and yep,
Okay. And your display is glowing but not doing nice things.
yep. Just blank.
Bianca, this is super annoying. I'm glad you didn't just quit altogether. Um,
Yeah.
wow. All right.
Maybe I'll put it under my tree and see what Santa can figure out.
Yeah, maybe Santa will come with a multimeter. Except we've done all the multimeter stuff.
Yeah.
Um,
I mean, especially on this new one where I've only gotten up the display, I've retested every connection,
right, right, right.
like
Um,
as I was doing it, and then again once everything was done to make sure I didn't bridge anything or short anything.
yeah. Okay. Let's try this. Share your screen again.
What screen specific? Oh, I'll share
New.
everything and you can tell me where you want.
Click in the serial window and hit Control C. Okay, and then hit Enter or anything else. So we have CircuitPython 9.2.8. Let me look at what I'm running. Um, so this
There's
is,
no way that could be.
oh, I mean, it's got to be something.
No, I know. I just mean like that's crazy if that's it. Like there's
Yeah, well,
oh, we got disconnected. Hang on.
2025-0528. Go ahead and turn the whole thing off and turn it back on again and reconnect. And it'll complain like it always does.
Yeah.
Wait a second. How come
What?
you have two Circuit Pi drives on your
I have no idea.
okay, that's interesting. Um, oh, it's in this P okay. Click the flippy triangle next to this PC.
Oh, okay.
All right, okay. So it's just showing up twice. It's not actually two of them. All right. So now that you're reconnected, open the serial dialog again.
Let's do
And there
Control
it
C,
goes.
Control D.
Okay. Well, Control D would restart. Control
Oh,
C
okay.
again. We'll just check that again and hit any other key. All right. 2005 0528 ESP32S3 4 megabyte flash PS RAM yada yada yada. Okay. One other possibility that
Hmm.
occurs to me at the moment. Um, so turn it off.
Hmm. Like hit the reset button.
No, like turn it all the way off.
Should I do
Unplug
that?
it from your computer.
Oh, I don't. Wait, do you want me to do the one that has like everything built or the one that has
Either one of them at this point.
okay. Yeah, I don't have the button to turn it off
Oh,
on
okay.
the one I have.
All right. So then unplug it from the computer
Okay.
and grab a battery. So the theory here is that possibly your Windows machine is interfering with the operation. So if you power it independently and it's not connected to your machine and the display comes up, that would be really interesting. I think it's low likelihood, but
Yeah.
possible.
Where do I plug the battery into? The microcontroller?
Plug the battery into the microcontroller, the big
Okay,
white
hang on.
connector on top. It goes in a particular orientation. It's got kind of a mohawk ridge to it that goes up toward you. Go ahead
They
and
don't even
stop
look like they're
sharing
the
your
same
screen
shape.
and hold something up so I can see.
Okay. So this is oh my
Yep,
God, that
that's
does
the
not help.
connector.
Hang on. Yep. And then the slot in the microcontroller. It doesn't look like they fit. Oh, the big white one.
The big white one.
Sorry. Bonk.
You have every excuse for anything that you do for the next year due to the frustration that you've been through.
Okay. And it's white.
And it's blank. All right.
Yep.
Okay. Uh, that's really weird. Um,
Because this wouldn't need the 5-volt boost, right?
it doesn't need the 5-volt boost. The display
Yeah.
runs on 3.3 volts. If you gave it 5, it would be really unhappy and maybe never work again. Um,
Yeah.
all right. Let us go back to the back of the display
Okay.
and just hold it up to the screen. Let me look at your little jumper things there, and let me see if I can see anything weird about that. Um, okay, where am I looking?
Yeah. There's like a wire going through them and connecting right here.
What? Oh, no, 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 no. Oh, no, 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 no.
What?
Oh, dear.
What?
Oh, crap.
What?
All right. Well, we know what the problem
Oh
is
no.
now.
What?
And the problem is that my instructions were not clear.
Uh-oh.
Okay.
Yeah.
Now, look at the back of the display
Uh-huh.
and look at the center of the display. We'll say center top opposite the connector that you use. Do you see how it says I am
Yeah.
0 and I am 1 and I am 2 and I am 3? Yeah.
Yeah.
Um, we're not supposed to short them together. We're supposed to bridge the gaps on each of those three, but not the I am 0 one.
Not the ones on the side.
Not the ones on the side. The ones on the side should not be connected to anybody.
Great. Uh, I don't have another display here.
You can just
Or
cut the
do I?
wires off um, of
Okay.
of where you shorted them together.
Okay. I don't have the wire cutters.
But you have a wire cutters available to you.
Yeah.
Okay.
Oh,
Now, when we talk about how important language is for engineering communication,
This is why.
This is why. It never would have occurred to me that someone would close those jumpers there. And we even had a conversation about the gaps between the jumpers. Um, and
Yeah, and I guess I was thinking the gaps between the nodes. I don't know what I was thinking.
yeah, so the things on the side we would call nodes or vias,
Nodes.
um, and
Yeah,
um,
those are
and they're not
jumpers.
jumpers, but you don't know that because you've never done this before.
Yeah.
Yeah,
And I was just having this conversation with Matt yesterday. I was like,
yeah,
no, I feel like I'm doing high level stuff without knowing the basics.
yeah,
So I'm like, I could be describing something wrong, and he would have no idea.
yeah. Well, and I use jumpers, which you did not know. Um,
No, I just looked for what said I am and just stop.
yeah, and I assumed jumpers meant the middle, and I even forgot that the IM 0, 1, and 2 come out on the side. Uh,
So if these are clo if I have the vias or the nodes closed but not connected, will that cause issues?
um, oh, you mean if
Like
the
if I have
hole
like a
has
little bit of
solder in it?
solder in there.
Yeah, no, that's totally fine.
Yeah, 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 but it's not connected to anything else. Okay.
Right. As long as you get them disconnected from each other just by cutting off what you have on top.
Okay,
And if
that's
there's any
fine.
solder bridge
Yeah,
left, remove that with
yeah.
a soldering iron. But it's okay if there's solder in the holes.
Yeah, yeah.
Yeah.
Okay.
But you see the little chevrons on the jumpers on the back of the display?
Yeah, yeah. Where it
Yeah.
says close for SPI.
You need to
Yeah, I
jumper across the chevrons.
great.
Okay, so let's go over this.
Yeah.
Whose fault is this? This is my fault.
I don't think it's like strictly your
It
fault.
is it is strictly my fault. You are new to
No,
this
because
and I failed to describe it properly. In the
but also
instructions and verbally, I did not give you a location. I only gave you labels.
But also, now I'm thinking it probably, I didn't watch Mike's video like all the way. So
Ah,
once I got a hang of what the like verbiage on the instructions means, I was
right.
like, okay, great. And when
Well,
it
and
said
everything
close,
else you were doing was vias. So why wouldn't
yeah,
this be vias?
yeah. So I didn't,
All right,
yeah.
so you get 1% of the blame for not watching the video through, and I get 99% of the blame for not communicating well.
This has been since Thanksgiving.
And
And
this
I
is
didn't
why
think to
it's
send you
hard
the
to do
photo
it
of it.
remotely. Because if I was there,
Yeah,
you would have said here, and I would have said no, over here, and that would have been the end of
yeah.
it.
Wow.
Yeah.
And I'm pretty sure Matt at one point said to me, he used the phrase jumper, and I pointed to the IM 1, 2, 3. He goes, those are jumpers. And I go, maybe I'm just using words I don't know. And I just like rushed past. Wow.
Oh man.
Wow.
Yeah. So
Well,
if you have a
tomorrow,
soldering iron and a wire cutter in a few minutes, you should be able to get both of
yeah.
them working.
You know what?
What?
I'm gonna say 0.5% blame on me
Okay.
because I even have a photo in the instructions I'm writing that says of me closing the wrong jumper or me closing the notes instead of the jumper.
Wait, so that is an extra 0.5%? So you're now at 1.5% blame?
Yes,
Okay.
yes. Now
All
I'm
right.
at 1.5% blame.
All
Yeah,
right.
or yeah, not yeah, taking away a half from you and adding it to me.
All right. Yeah,
That's
yeah, yeah. So
actually
you're at one and a half
funny.
percent blame and I'm at 98.5. That's good. I
Yeah,
can I can
because
deal
let me
with that.
share my screen. I confidently put in put in this photo, and
Oh,
these aren't even merged together yet.
yeah. If you had uploaded the instructions and said, "Hey, would you check this?" Um,
Yeah,
Yeah, but why would you? Because everything else has
Yeah,
been vias. Um,
yeah,
yeah. Do you see on the center right there?
yeah.
Yeah.
You know, honestly,
Yeah.
I'm happy we just figured it out because if I had
Oh yeah.
soldered that correctly, I genuinely don't know how long I would have been able to without like going mad.
Yeah, yeah, yeah. It's really frustrating.
Yeah,
Now,
yeah,
take this
But
and multiply it by somewhere between 1 and 10,000 connections
yeah,
and have a whole bunch of technicians who are not the people who designed the circuit
yeah,
assembling them for a spaceflight project,
yeah,
right? You see how many things can go wrong. I suspect it will
yeah,
be a long time before you forget this.
yeah. Oh my gosh.
Yeah.
I gotta tell Matt because he was like last night he was looking at it too. He's like, yeah, 'cause I'm like, I want to get it working before my meeting. He's like, Becca, everything's connected. He's
Yeah,
like, I
yeah.
don't understand.
Even things that shouldn't be connected are connected.
Yeah, apparently.
Well, and three things that should be connected are not. Um,
Yeah.
yeah.
He even said, because I said the jumper, and he goes, "That's not a jumper." I go, maybe I'm just saying the wrong."
And that's the other thing is you got to pay attention to the words in
Yeah,
really, really careful detail. If you go,
yeah,
yeah, that's not a jumper, you're not going to forget that soon either, right?
yeah.
Um,
Because it's so funny because Matt says I have a habit of like making up words for things,
yeah,
and which, for the record, they say being able to communicate across a language barrier, is a sign of intelligence.
yeah, yeah,
Like one time I forgot the word for moth, then I called it a night butterfly,
yeah.
and he knew what I meant.
Right, right.
But in this case, probably not great.
Well, so, I mean, jumper is like somebody who stands on their feet and then bounces off
Yeah,
the ground, right?
yeah,
That's a jumper. Or if you're from the
yeah,
UK, it's a sweater, um,
yeah,
right?
yeah.
So yeah,
I'm
um,
definitely gonna have to look back. I know you sent me a couple electronics books that your niece was also asking about. I'll probably have to get one of them and just or see if Matt has any
it
textbooks
it
and just
might
get
it
the
might not
basics.
help you with that particular problem. Um, this
Okay.
is an entirely a terminological problem. It's not a concept problem,
Yeah,
right?
that's
So,
true.
um,
Yeah,
yeah, so clarity is really important. And the other lesson here is
yeah,
that the other thing that is of vital importance that we did not do, and this is my fault as well,
yeah,
is that we didn't trade pictures,
yeah,
right? Or a diagram that shows the position that you should be working on. Right?
yeah.
So we can talk about things in words, but if we're referring to a location in actual physical space, there's
We
no
should have a
substitute for
photo.
having a map,
Yeah, yeah,
right? So if I say, let's go walk
yeah,
to that hill over there, and you go, oh, that one with the something something on it, I'll be like, yeah, and then we'll walk to two different hills, right? Whereas
yeah,
if we're on a map and we point and we say, let's go walk to this hill, this one over here on this map, yes,
yeah,
that one. There's no uncertainty.
yeah,
And this
yeah,
happens all the time in engineering meetings, right? Where people
yeah.
talk about things and they're like, okay, we're going to do this. And if you don't draw it, or at least write
It
down what
doesn't,
it
yeah,
is, the this
yeah,
means different things to everybody.
yeah. Like, oh gosh, what was it? How do I increase the volume of my computer?
Right, right, right.
Literally volume,
Yeah,
like
yeah, yeah.
3D volume or volume like sound. We got to come up with more words for things. Actually, well, no. I got to make sure I know the words for things.
Well, and that's the
Man,
other thing. And I'll give you another tenth of a percent of blame
yeah.
for not taking me up on any extra question and answer.
Yeah. The problem is I thought I knew it. That's
Yeah,
the
yeah,
problem.
yeah. That
So,
confidence is really important.
yeah.
But you have to
I can't
temper the
believe,
confidence with skepticism because otherwise it will
yeah,
bite you. And now you know that.
yeah. I can't believe at one point I didn't, this is the first time in over a month I've held up the display to you.
Yeah.
I can, yeah. But in my mind, yeah, I closed it. They're connected.
Yeah. And in my mind, you
You heard the
closed it.
beeps.
You even buzzed it out. There is a
Yeah, I
way
buzzed it
to
out with
connect.
Elon.
There is a way to connect those vias, the IM 1, 2, and 3 vias that you used, to
Yeah,
something in order to make it work the same way as closing the jumpers on the middle back of the board.
yeah,
I don't know what that something is, but there is a way to do that.
yeah,
But it's not shorting them together.
yeah,
It's
yeah.
kind of the equivalent of shorting MISO and MOSI and clock together.
Oh, okay.
But it's an
Okay, well, yeah, I
internal
can see that.
communication thing for the display. So you won't see
Yeah,
it on MOSI MISO clock.
yeah, great.
Do you feel slightly better now?
I do. I feel like I need a nap, to be
Yeah,
honest.
absolutely. You earned a nap.
Yeah, you too. Yeah, yeah,
This is what troubleshooting is like. This is debugging.
yeah.
Um,
And it's funny, we talked about doing the easy stuff first, doing
yeah,
like
yeah,
the quick checks.
yeah, yeah. Right. Well,
Yeah,
what I should have said is show me the back of your display.
yeah. And I should have been like, here. Well, because we had the whole conversation about like you wouldn't visually be able to tell anything. You'd have to use the multimeter to actually test the connections. And I was like,
Right.
that makes sense. So I don't need to show you that I did this right. I know I did this.
Right. Yeah. So whatever you buzz, the electrons were going to go there. It just wasn't the right things.
Yeah. Oh,
So, okay. So for the publication that we just had that's like actually
yes.
published now, like
Yeah.
hooray, absolutely. Um,
Yes. Oh yeah, I forgot we haven't met since it's been published.
yeah, yeah, yeah. Yeah.
No, it makes me feel good that I guess that's still part of the electronics, obviously, but I soldered correctly. I used the
Yeah.
multimeter correctly. I tested correctly, so
Yeah.
just
It
didn't know what a
was
jumper was.
a difference in understanding of a single word.
Yeah,
And that's what makes bridges stay up or fall down.
yeah. And let me tell you, that's going to be a great section in the narrative
Yeah, yeah, yeah.
instructions. Yeah,
Yeah, apparently that section needs a little clarity. I might
yeah,
could include a picture of that particular step.
yeah. I will definitely have one added.
Okay,
Do
good.
not fret. Yeah.